Hello, everybody. It's time for common logs and change of bases. A big day. It's kind of like a good way to solve logarithms. So we'll get into it. And the first section right up here, the warm up, of course, just like class. Go ahead and hit pause and do it, and then come back again and resume. And I'll work through them as quickly as I can because this is all just review. Okay, go. Well, that is hit pause and go. Okay. All right. Hopefully you actually did this to get the value out of it. When we're expanding, we notice that things that are multiplied inside of a single log can then just be added. Well, not plus, equals. So it's equals log base 2 of x squared plus log base 2 of y. And then, of course, if it's on the bottom, it's not an add, it's a subtract. So it's minus log base 2 of square root of z. And then we say, okay, hey, I remember a log is a power, so the power really belongs back on the same line. Well, that's just 1, so whatever. And then this square root of z is the same as z to the 1/2 power, so I could bring that down, and then I would have 2 log base 2 of x plus log base 2 of y minus 1/2 log base 2 of 2. Now, what is log base 2 of 2? Log base 2, wait, no, that's a z, sorry. Looks kind of like a 2. I gotta put a crossbar in that z because it fooled me. Okay, well, that's it. Now when we're condensing, everything reverse. What color should I use? Green. So all of these numbers out front will go up to be the 2/3 power. This will be y cubed. This one's kind of already condensed to some measure. Now, everything that's positive goes in the top of the fraction. Everything that's negative goes in the bottom. So you can just write it out in a single step. Log base 4, it will be x to the 2/3. And then this stuff will be on the top as well. So I guess I'll put 2x to the 2/3 power over x squared. And if you remember your simplifying rules where you can't have a fractional power on the bottom, actually that's about as simple as you can get that one. And then it looks like y cubed on the bottom. Okay, and that one should be done. Solving. Wonder if I could use some more space. I think I'll give myself some more space. On this one, we can't solve it straight away, but we can say, fine, log base 10, we're going to condense this now. Things that are added can be put into a single, I'll put a bracket, z times z plus 9 equals 1. And then we remember our mapping rules. It says this 10 to the 1 power equals all that. So 10 to the 1 equals z times z plus 9. And then when we solve that, what do we get? Z squared plus 9z. It'll end up being minus 10 equals 0. Can I think about that? It'll be z plus 10, I think. Z minus 1. Does that work? Does that fall out? I think so. Yep. So z is therefore equal to 1 or negative 10. Now, I'm not going to forget to double check these answers. I circle it and say, what if I take that 1? Can I plug that 1 in here? That's log base 10 of 1. Sure, that's fine. That's easy. And then log base 10, that ends up being log base 10 of 10. That's 1. 0 plus 1 equals 1. Good, that works. Negative 10. Can I take the log base 10 and negative 10? No way. No logs of a negative, so that's out. That is extraneous. Okay, moving on. I can't show you this in the calculator, but hopefully you can figure this out. Calculator does do logs. I'm guessing you figured this out already. If you type in on your calculator, find log function, do log of 6, it's gonna, what is it gonna give you? 0.7782. Hit pause and try it and just do it, make sure it works. Now, of course, what base is understood? This is common logs now. What base is understood if you don't have one? Well, log base 10. And so if you want to test it out, try. What is 10 to the 0.7782 power equal to? And then you should see that that gets you back to 6. it's worthwhile trying this and testing it out. Okay, so type this one in, and hopefully you'll see that you get a negative 2.5, what was it, 22? I don't have to retype this in, I can't read my old notes. So let me type it in. You do it while I talk. Log 0.003. Negative 2.523. And since a log is a power, it's very sensitive to decimals, so it's good to keep more than 3 sig figs. You'll hopefully understand why. On this one, you could type all this in, but if we're clever, we remember, hey, that's interesting. That's the same as the log base 3 plus the log, no, why did I say log base 3? My bad. It's a log base 10 of 3. You don't have to write it, but plus the log base 10 of 10 to the 8th. Lo and behold, what is that? What power of 10 will get me to 10 to the 8th? Well, 8. So why don't you try it both ways, log base 10 of 3 plus that, and if you do that on your calculator, you should get 8.477. And I'll go back and circle those answers. Just remind you that, just to remember these properties, and you can use them when you're calculating, just like you can use them when you're solving up here. Okay. Now, how in the world do I do this one? There's no log base 3 function on the calculator. Well, maybe there is if you search for it, but you don't need it because, well, what do we know the answer to this? What power of 3 will get me to 9? Well, we know the answer is 2. So, try this. Find the log of 9 and divide it by the log of 3. Just do it. See what happens. Hit pause. Type it in. Actually, I didn't write these down. I got to do these. Log of 3, yeah, 0.9542, log of 3, 0.4771, and if you divide those out, 0.9542 divided by 0.4771, guess what you get? 2. And this is effectively the change of base formula. I can find log base anything as long as I have, I can use log base 10. It's kind of cool how that converts between them. I'll let you ponder why that works on your own. Just think about that. That's a good thought question. So try the next one. Hit pause, do it. Should have gotten log of 400 over log of 24. It looks like a base. Let me rewrite that. And did I write those down? Let me write that. I didn't write those sub ones down. Log of 400, 2.602, and log of 24, 1.38. And it looks like that is going to be 1.886. Or thereabouts. So it works. It's kind of cool. And if you want to try it, what is 24 to the 1.886 power? Test it out. Does that get you to 400? That's probably approximately equal to. Okay. Last one, it looks like, if you want to test that out, it looks like it should get you to -3. Is that right? That's what I have written down on my other sheet. Let me see. What is 5 to the -3 power equal to? 5 raised to the -3. Hey, nice. 0.008. Cool, it works out. Okay, now we remember how to solve the simple equations by mapping, and that is still a great and excellent skill. So just to refresh your memory on that, I think I might want more room in here. Where is my stupid cursor? Let me hit back to draw, type, there. So when we mapped, we said, well, the basic, we just defined logs as being y equals log base b of x. And we said, well, that's just the way it is. Now we're going to say that maps into a log is a power, so this base of b to the y power equals x. And we define that as a mapping between the two forms. I just put an outline around that. So what that says is, well, if I take this one right here, I'll do it in purple. If I take this one here and map it down, well, that'll be my power in this case is x. So x is equal to log base, well, the base is 4 of 19. Okay. Now we know how to do our change base formula here. And if we do that, I think we get, I don't have any room here, but I'll put it out. X equals 2.124. And so it looks like I had written down. Try it out. Now, we come over to the one to the right over here, and we're like, that seems solvable. I have 3 to a power and 7 to a power, but I cannot map of that. Oh no. Oh no, can't map. Need another way. And so this is an important point to point out. We can solve by taking the log of both sides. It's kind of like taking the square root of both sides in the equation. I take the log of both sides and it should still be equal. So I'll take the log. I'll write it out. It's going to be too messy if I be lazy. I'll take the log of that side and the log, I'm going to write it in a different color. Log of 4x and the log of 19. And then we, no, it's not 4x, it's 40 to the x power. Silly me. And then we use our properties and say, hey, I remember that. X comes down, x times the log of 4 equals the log of 19. And then x is equal to log of 19 divided by the log of 4. And you say, hey, cool. Isn't that exact? Well, that's still 2.124. And then, whoa, cool. The change of base formula just kind of popped out. So in a way, we just proved the change of base formula. It works. If this whole log of both sides process basically gives me my change of base formula. Neato. All right, well, let's try it on B. Try doing it. Don't wait for me. Hit pause. Go. And I am going to be lazy on this one. Log of that side. Log of that side. And just do it. Hit pause. Don't forget, now I'm relying on you guys actually doing this. Otherwise, no better than any other video if you don't actually take the time to do it. Okay. Hopefully you actually did it. These powers come on down, and then I have 5y. Well, I'll try to color code this thing, right? Y minus 2, and then I had times the log of 3, and then that's times the log of 7. These are both log base 10, of course, because I'm just taking common logs. I can take log of base anything, but since calculator understands log base 10, those are generally easiest. Now, can I solve this whole thing for y before I type anything in the calculator? Because yes, I could get a decimal for this and then multiply it by 5. I could get a decimal for log of 7, but then I'll introduce round off error. Ideally, I don't do that, so I don't compound round off error. See if you can solve this for y. In other words, you got to get y all by itself on one side of the equation. Hopefully you can see that this is going to distribute out, and I'm going to write small, so hopefully I can fit it without. So this will end up being log of 7 times y minus 2 log of 7. Okay, fine. Now if I get all the y's on one side, I'm going to want to move that over to that side, and then I'll get log of 3 times 5y minus log of 7 times y, and then that's going to be equal to, that was a minus 2, right? Minus 2 log 7. Remember GCF? See how there's a y here and here? If I GCF y out front, don't I get y times log of 3? Well, that's not log base 3. It looks like log base 3. Log of 3 times 5 minus the log of 7 equals my negative 2 log 7. I'm really close to solving this for y. And so y is equal to, dang it, y is equal to negative 2 log 7 divided by, stupid thing, when you zoomed in so far, it's so skittish, log 3 times 5 minus log 7. Okay, well, it's something I can type in my calculator as long as you're careful with PEMDAS and all the typing process. And then y should be equal to negative 1.097. Stupid thing. Negative 1.097. Try it for yourself. Don't just rely on me. Okay, almost done. Nice. Inequalities, same deal. Remember how we mapped this the other day? We can still do that. And mapping is still a good way. I mean, it's still an excellent way. I like it just as much. Because what is this? What is a log is a power. My power is x plus 5. So x plus 5 is greater than log base what? Log base 3. 76. And solve it the way we always did. X greater than, we can calculate log base 3 is 76 if we want, minus 5, and we're all good. Just as before, I cannot do that with this one. Now remember, I have to be careful when I'm doing this, that my base is bigger than 1. If I have fractional bases, it messes up the inequality because it's effectively a negative power. Remember, when I divide by a negative with inequality, it flips around. So anyway, 8's a nice base. Well, anyway, it's bigger than 1. If I take a log of both sides, I'm tired of green. I've got to change color. Go back to purple. If I take the log of that side and the log of this side, hopefully you can see I get 6x times the log of 8 less than 3 minus 2x times the log of 43. And, well, let's be lazy on this and simply get decimals, just because that's okay as long as you keep a lot of decimal points. I don't want to, I mean, this is a bit tricky algebra. I don't know. Some possibility of introducing error. I want you to be cognizant of round off error, compounding in problems, but for now, if I do 6 times the log of 8, I believe you get 5.419. And that's less than, what does it end up being? 4.9? Is it 4.906? Can't read my handwriting. Minus 3.269. And remember, or 3.267. I'm relying on you guys actually doing this and not just copying. Anyway, solving 8.686x less than 4.906 or 00, whatever that was. And then so x is less than 0.5641. Anyway, that's what I had last year. Okay, hopefully that's good, and that gets you through the next assignment. See you guys.